Okay, number 30. Mary Jo decided to solve the equation 3x minus 2 equals negative x minus 6 by entering each of the expressions into her graphing calculator. To solve the equation as a system, she entered y1, she entered the first expression, and y2, she entered the second one. When she used the calculator to find the intersection, she found that x equals negative 1 and y equals negative 5. Show the work to check to see if Mary Jo found the correct solution for x to the linear equation. So right now you should be thinking of systems, and if you graphed this, it should be two lines and they should most likely intersect somewhere. So Mary has stated, by listing these values, that she found the intersection point to be negative 1, negative 5. What I would do if I were you is go to your graphing calculator and enter those functions just like Mary Jo did into y1 and y2. I would then go to my graph to see, is negative 1, negative 5 really the intersection? To me it looks like it is correct, but remember, we never want to make any assumptions. We want to be able to prove it. So if I look at my table of values, I can see it does look like the solution because negative 1 goes to negative 5 for the first equation, and negative 1 also goes to negative 5 for the second one. So I am aware already that Mary Jo is correct. However, the question is asking for you to show the work. So since this is a linear equation up above right here, I could take that equation, and what I'd like you to do, what this question is asking, is for you to get x by itself. So you're going to solve for x, use your properties of equality, and in the end, we already have an idea that she is correct, so I know I should get x equals negative 1. After showing your work, I would state down here, Mary Jo is correct because, or Mary Jo is incorrect because. Go ahead. Alright, number 31. Find f of negative 2 for the function. And with this function f of x, I see that they have given me two different pieces. So let's think about this. F of negative 2. Negative 2 is taking the place of what would normally be the letter x. Remember? So x is standing for my input. So I need to input negative 2 into one of these expressions over here. Notice I am given two different domains. So the function reads f of x is equal to 3x squared minus 1 only when x is less than 1. So I want you to think about, is x less than 1? If so, you will input negative 2 into this expression. Or, is our value x, negative 2, greater than or equal to 1? If so, then you will use this expression. So you're only going to use one of them, whichever one negative 2 satisfies. So you're going to go ahead and plug in negative 2 into whichever one you chose. And please make sure that you plug it in parentheses. Follow your PEMDAS, only enter in one operation at a time. And then you'll get your final answer for what f of negative 2 is equal to. So when negative 2 is the input, what is the output? And then you are done. Go ahead. Number 32. Identify the turning point of the function, f of x, by writing its equation in vertex form. Wow. All right. So if I reread this again, identify the turning point. Remember, that's just another name for the vertex. So I need to find the vertex. When I look at my function here, I notice that it would have a vertex because it would be a parabola. This is a quadratic equation where the highest exponent is a 2. I know that my parabola would be happy because the leading coefficient here is a 1. It's positive. But the question states that you must do it by writing the equation in vertex form. Remember that vertex form is just a name for the form we can get a quadratic into after we complete the square. So the directions here did not tell you to complete the square, but you do need to be aware that that's what it's really saying when they say vertex form. Right now it's in standard form. You need to get it in vertex form and then state the vertex, the turning point, when you are done. So I'll start you off. Remember completing the square. Okay, when I look at my equation, I do not like this plus 8 here because it's not a perfect square. So we're just going to scoot him to the side. So now it's up to you to find the missing number that goes here. Remember that missing number is half of b. Half of b, then square it. You will find that missing number and put it here, and you'll do the opposite over here. Okay? In the end, you should get something that looks like this. A perfect square binomial with your constant over here. This is your vertex form. Once it's in this form, you should be able to state the vertex, so don't forget to do that. Remember that you should be stating an ordered pair. What's also really nice about this question is you could input the function into y equals and find the vertex that way. Remember, doing this is just a checking technique because you do need to show your work, but it's nice to know that whether or not you got the right answer. Go ahead and complete the square. Number 32. Graph 2x plus y is less than 7 and state one point in the solution set. So I need to graph this inequality, and in order to graph any function, we always need to have y by itself. So you need to get y by itself, which I'll help you out here. On the same side as y, I do not like this 2x, so I need him to be on the other side. So let's get him there. So I'm left with y is less than. I see that this says 7 minus 2x. I could rewrite it that way, but I also always like to write it with my x term first and then my constant. So I am going to write it as negative 2x. And 7 is positive, so plus 7. Now you can identify, if it helps, your slope and your y-intercept, so you can graph this line. Or, the nice thing about this is you could input this into y equals, look at your ordered pairs in your table, and plot all of those points. Once you do that and you have your points, please remember that you need to decide what type of line you are going to use. This means, will you use a dotted line or a solid line? Okay, so you're going to look at this inequality sign, read it out loud, say it out loud, and decide what type of line. And our other decision that we make with inequalities is which way do we shade? Will we shade above the line or below? You will also read the inequality out loud to help you decide which way you will shade. Okay? Remember, the shaded region represents your solution set, and this question does tell you to state one point that falls in that region. So somewhere on your page, you need to list one point. Go ahead. 34. Jonathan has been on a diet since January 2013. So far, he has been losing weight at a steady rate. Ooh, I hope you're all thinking of a certain function right now if you see the word steady rate. I know I am. Based on monthly weigh-ins, his weight W can be modeled by the function W equals negative 3m plus 205. Where m is the number of months after January 2013. So that was nice of them to give us the equation here. I hope you notice that this equation, which function it is linear. Okay, it looks like mx plus b. They're just using w and m instead. And I also knew it should be linear because they used the word steady rate, which is also another way to say constant rate. So letter A. How much did Jonathan weigh at the start of the diet? Remember that anytime you have a story that's at the start, the time is 0, which is always our x value. Okay, or some of you might just see it by looking at the equation, and that's fine. You can go ahead and write your answer. Some of you may want to input your 0 for x to see what your output y is. In this case, m is our x value, and w is our y value. So go ahead and find Jonathan's weight. How much weight has Jonathan been losing each month? I hope you're already thinking about this. They did mention the word steady rate before. Remember, your rate of change, you could also be thinking of your slope. What's the slope in this equation? That's how much weight Jonathan is losing each month. So you can write that underneath letter B. Letter C. How many months did it take Jonathan to lose 45 pounds? I like this question because it has multiple steps involved. if Jonathan loses 45 pounds, you need to think of how much does he weigh then? So if you had from part A that his starting weight was 205, if he lost 45 pounds, then Jonathan should now weigh 160 pounds. Okay, so if W equals 160, then you need to see, well, how many months did it take for him to get there? You could set up a table of values and figure out how much he would weigh after each month and see how many times it takes you to get to 160. Or you could input 160 for W into that equation up above, just show your work down here, and solve for M. Please make sure that you answer the question by saying it will take Jonathan however many months. Go ahead. Number 35. Yolanda owns 4 rabbits. She expects the number of rabbits to double every year. Ooh, I'm already thinking of a function in mind, something that doubles, which is multiplying by 2 over and over and over again. I hope you are too. Letter A. After how many years will she have 64 rabbits? What I would do is she starts with 4. Why don't you list out a sequence of numbers and see how many years it takes you to get to 64. Keep in mind this is our starting amount, so after 1 year will be here, and after 2 years will be here, and so on. Just be sure to state the number of years it takes to answer the question. Letter B, write an equation to model this situation. So in order to come up with the equation here, we need to know what type of function this models. Do you know what kind of function models a sequence that is multiplying by 2 over and over and over again? I hope that you're thinking of a geometric sequence, and geometric sequences model exponential functions. So my geometric sequence formula for my reference sheet states this. I'm going to write this down as my guide. Remember, this is never an answer. This is always your guide to get to your answer. So if I need to write an equation, I need my equal sign. A sub 1 stands for the first term in your sequence. Use what you have up here. Remember that R stands for the common ratio. What is the number you're multiplying by over and over and over again? And then you can simply keep n minus 1 here. And I'm going to use my function notation instead of a sub n because this is a function. And then that would be your equation to model the situation. The use of a grid is optional here, so if you wanted to, you could plot your points, your sequence as a set of points. So at year 0, or your starting amount, there were 4 rabbits. You could plot that. Year 2, you should have 8. Now you're going to notice you may want to change your scale on your y values so you can make it fit. However, this is just optional, so you do not have to do this. Go ahead and finish writing your equation. 36. Create a box plot for the ages of people listed below. Alright, so remember that in order to make a box plot, we need what's called a 5-number summary. You must always record your 5-number summary or you will not receive full credit. Consider this part as showing your work. So your 5-number summary, remember it was your minimum, Q1, the median, Q3, and your maximum. You can get all of these values in your calculator, and I'll show you the steps now if you forgot them. So you'll want to go to your Stat button. We are going to edit our list so we can input the data. Clear whatever is there. Remember, to clear, you can just go up, hit clear, and it should go away when you go back down. Okay, you're going to enter all of your data in L1, and now we want our 5-number summary. So after you do that, you will go back to Stat, go over to Calc, and remember it's 1var stat, so you'll just hit enter a bunch of times until it gives you all of your data. I'm just getting an error message right now because I did not enter any data, but once you hit enter, you'll have all of your values pop up. If you scroll all the way down to the bottom, you should see your 5-number summary. Please copy those values into your worksheet. And then you are ready to make your box plot. So if I look at my values here, I can already tell my minimum is 7, and it looks like my maximum is 60. So you're going to need to create your own number line. It needs to go at least to 7 to 60. I'm just going to go to 0 to 60 to make it easier. Okay, then I like to fill in halfway is 30. I also need 10 and 20 in here. And 40 and 50. So go ahead, use your 5-number summary, and please construct your box plot. Do not let it touch your number line. Go ahead. Number 37, graph the system of equations. Remember, a system just means that there's more than one. You will definitely see systems on your exam. And state the solution. So the solution is going to be the intersection point. Okay, remember, we can never graph anything unless y is by itself. And when I look at my equations here, y is by itself up here, which is very nice. I hope you see what sort of function this is going to be when you graph it. Okay. It would be nice if you made a table of values from your calculator. You'll plot all of your points, put arrows, and label your equation. With the next one here, y is not alone, so you'll want to get y by itself. I'll help you out. Let's get rid of our constant. So we have 2y equals x plus 1. Now I need to divide by 2 here to get y alone. And I must divide everything by 2 on the right-hand side. So my equation reads y equals x over 2 plus 1/2. Now I could also put a 1 here. Alright, and now I will have to graph this. If it helps you, I would make a table of values for this also by entering it into my calculator. Please be careful when you do this. If you're going to enter it into your calculator, it should look like this. When I go to y equals, I want 1/2 x. So if you'd like, you could enter it in as a decimal, just to sort of play it safe. So you could do 0.5x, and then you can also do plus 0.5. You'll get your table of values. I would copy a bunch of them and plot them until you feel like you've noticed the pattern, and you can continue making the points on your graph. Make sure to put arrows and label also. Okay, so you should end up with a quadratic and a line, a parabola and a line. They should intersect maybe once, twice, or maybe never. Whatever the solution is to the system, remember you're going to write an ordered pair somewhere for number 37. Go ahead.